I'm going to go ahead and do one of each type of problem just as an example for you guys. So that way if you get stuck, you can see and then try and do some more on your own. I'm going to start with number 1b, which is log base 5 of 125. And they want us to evaluate the logarithm without a calculator. We need to show our work. So because it's a log base 5 of 125, I know that 125 is equal to 5 to the third. Because of that, I can substitute 5 to the third in for 125. So I end up with log base 5 of 5 to the third. When the log base and the exponential base are the same, it'll always be equal to the exponent. So log base 5 of 5 to the third is equal to 3. Therefore, log base 5 of 125 is equal to 3. And that's our answer. I'm going to go ahead and do 2a now, where I want to write an equivalent equation using a logarithm. Again, I want to show my work. So what I'm going to do is on 2a, I have 4 to the fifth is equal to 1024. Because the exponential base is 4, that means I'm going to use a log with a base 4. So I'm going to apply a log base 4 on both sides of the equation. So I end up with log base 4 of 4 to the fifth equals log base 4 of 1024. Because again, when the log base and the exponential base are the same, it's equal to the exponent. So this side, the left-hand side, will simplify to 5 equals log base 4 of 1024. And then that is my answer. For number 3, we're doing something similar but backwards. This time I want to write it in exponential form instead of logarithmic form. So I'm going to go ahead and do number 3b, where I have log base 9 of m equals n. My log base is 9, which tells me I'm going to use an exponential base of 9. So I'm going to put an exponential base of 9 on both sides, which means then log base 9 of m is an exponent. And then on the right-hand side, m is going to be an exponent. Again, when the exponential base and the log base are the same, it's going to be equal to m. So this side simplifies to m equals 9 to the n. And then that is our final answer. So I'm going to go ahead and do 4a. In 4a, I want to evaluate the log base 4 of 8. What I'm going to do is I'm going to set it equal to x. Really, I could set it equal to any variable, but I always pick x. And then I'm going to get rid of the logarithm. To get rid of the logarithm, we have to write it in exponential form. So I'm going to apply a base 4 on both sides. When the exponential base and the log base are the same, this side will simplify to just 8 equals 4 to the x. Now what I want to do is I want to get a common base between the two. So I know that 8 is equal to 2 to the third, and 4 is equal to 2 squared. These both give us a base of 2, so I can rewrite 8 as 2 to the third equals 4 is 2 squared, and then that's raised to the x. So this equation is still 8 equals 4 to the x, only I've written 8 as 2 to the third and 4 as 2 squared. When we have an exponential equation where the bases are the same, we can set the exponents equal to each other. So I'd have 3 equals, now here I have an exponent raised to an exponent, so we multiply. 2 times x is 2x. Then to solve for x, I divide both sides by 2, and I end up that 3 halves is equal to x. And then that is my final answer. Looking at number 5, I'm actually going to do 2 problems for number 5. I'm going to do 5a and 5d. So starting with 5a, I have 4 to the x equals 64. Again, this is an exponential equation because my variable is an exponent. So I want to see if I can't find a common base. So in this case, I know that 4 to the third is equal to 64. So what I'm going to do is on this side I have 4 to the x equals, instead of 64, I'm going to write 4 to the third. Again, the equation is still the same. It's still 4 to the x equals 64. I've just rewritten 64 to be 4 to the third. And then again, when the bases are the same, we set the exponents equal to each other, so x equals 3. And then that is my final answer. Looking at 5D, I have log of x equals 2. Now a log without a base has a base of 10. If you want to write it in, you can. You don't have to. But I want to get rid of the logarithm to try and solve this. I have to rewrite it as an exponential equation. So I need to apply an exponent base of 10 on both sides because I have a log base of 10. So I would have 10 to the log of x equals 10 squared. When the exponential base and the log base are the same, it'll be equal to x. So the left side simplifies to x equals 10 squared. 10 squared is 100, so x equals 100, and then that is my final answer. I'm also going to go ahead and do 2 problems for number 6. I'm going to go ahead and do number 6b and number 6d. And again, I'm evaluating these without a calculator, and again, we need to show our work. So on 6b, I have the natural log of 1 over e to the 5th. I don't like that it's 1 over e to the 5th. So what I'm going to do is I'm going to take the reciprocal of that. When I do that, that will make the exponent negative. So I end up with the natural log of e to the negative 5 over 1, but anything divided by 1 is just itself, so we don't have to write that. Now a natural log has a base of e. And again, when your log base and your exponential base are the same, it's always equal to our exponent. So in this case, this will simplify to negative 5, and then that is our final answer. I also want to do part D. D is a little tricky. It is e to the natural log of e. So the first thing I'm going to do is I'm going to look at the exponent, the natural log of e. So the natural log of e, because natural log has a base of e, whenever the base and what you're taking the log of are the same, it's always equal to 1. So this really becomes e to the first, which is just then e, and then that would be my final answer. Okay, I'm going to go ahead and do 2 more problems. I'm going to do number 7 and number 8. In number 7, it says, suppose you make an initial investment of $750 in a savings account at 2.7% interest compounded continuously. How much will be in the account after 4 years? Because they tell us that it is compounded continuously, that tells us that we're going to use the equation PERT. So A equals P times E to the RT. What I like to do in these problems is I like to list out my variables, A, P, R, and T. Remember that E is actually a number. So I don't know A. P is my initial investment, which is $750. R is your interest rate, and it has to be written as a decimal, so that would be 0.027. And then T, we want to know how much there is after 4 years, so T is 4. And I'm trying to figure out how much I have, so I'm trying to figure out A. So then I just plug everything in. So A equals 750 times E to the 0.027 times 4. This then becomes A equals 835.54, and then that's my final answer. For number 8, it says if $1,200 is invested at 4.2% interest compounded monthly, how much will there be in 7 years? So this problem, I'm told it's compounded monthly, so I just use the compound interest formula, which is A equals P times 1 plus R over N raised to the N times T. And again, what I like to do is I like to list out what my variables are. So P is my initial investment, which is $1,200. R is my interest rate, which is 4.2%, so 0.042. N is the number of times it's compounded. Since it's compounded monthly, N is 12. And then T is 7, because I want to know how much there is in 7 years. And I'm looking for how much there is, so I'm looking for A. A is what I want to find. So I would have A equals 1200 times 1 plus 0.042 divided by 12 raised to the 12 times 7. So then, to keep solving, I would have A equals 1200 times, if I figure out what the parentheses simplify to, that's 1.0035, and then 12 times 7 is 84. And then if I multiply that out, I end up that A is equal to $1,609.31. And then that is my final answer. Okay, hopefully that helps if you guys get stuck. If not, feel free to email me, or again, you can ask questions when we meet on Google Meet. All right, thanks guys.